Hi, I'm Printed for Fun, and in this video I will give you a tutorial on how to scan with the Revopoint MetroY Pro, and I will also share my, I would say, custom accessories and like workflow improvements that simply make it far easier and more efficient to scan with the MetroY Pro. Here you can see the original case, but before looking at the contents of the case, let's have a look of the contents I have removed from the case. So, that's all I removed. Maybe you have watched my unboxing. These are like, here is like paper accessories, the calibration certificate, and this little bust. I don't need them while using the scanner. Also, we have the 12-volt power brick for the dual axis turntable. I replaced this one with like an adapter cable. I will show you later. The adapter cable has a USB-C input using the PD, like it's the power delivery protocol of USB, to get 12 volts to the turntable. So it's basically USB-C to barrel jack adapter. Same applies for the scanner itself. Normally it uses this two-part power brick outputting 12 volts, but I also replaced this one for the wired use case, so when you have directly wired to the PC with such an adapter cable, so I can use the space that's freed otherwise. So now let's open the box again and have a look on what I have inside. So maybe let's start with top, since this is the most uninteresting part. That I simply remove the paperwork, and I quite like to put my markers here in the front. Normally they're put behind, but so they are quite easily accessible. One additional point you have to keep in mind if you buy spare markers for your scanner, since you will like they are usable parts. So at some point you have to buy additional markers. The markers are high reflective ones. So if you're like cheap like I am, and you want to buy markers on AliExpress or Amazon, the cheapest markers you will get most often are like plain white and not in this high reflective coating. And these simply won't work with the scanner. So the scanner needs the high reflectiveness. It's like with all laser scanner, this applies. Like the white plain markers are only for the very basic entry scanners that only use like infrared modes. The MetroY Pro also can use smaller markers and larger markers. I also have 10mm markers of my Trackit I use for larger scans, but they are in the case of my Trackit, since I would say 6mm markers are the sweet spot for the MetroY Pro. So now turning the case back, let's first unpack all of the contents of this case. So we can later look at them in detail. We have the scanner, and maybe you have noticed this is like one of the more interesting parts here, the scanner turned. So normally we have the power cable here on the bottom, then we have like this separating piece of foam and the scanner on the top. But I have designed like here some lens protectors, and with these lens protectors it doesn't fit in there like this. I didn't want to like cut around in the foam, and I luckily noticed it perfectly fits in this location, and it's nearly flush with this top foam, so it's still quite good protected. So let's take out the scanner. Then we have the stock USB cable to connect the scanner wired. Since I most often use the scanner wirelessly, I very rarely use it. But since sometimes you're like in a higher F environment, when they're like you're in a building block with a lot of small flats, a lot of Wi-Fi networks, and your Wi-Fi connection could be affected. So having this like wired cable as a backup in your case is quite sensible, I would say. So I don't want to like completely remove it. Then we have the tripod for the dual axis turntable. This also didn't change. I quite like that in the new revision, like compared to the Metro X, the scanner itself has a threaded insert, and I don't need this kind of shelf the MetroX was placed on. But let's move this to the side. Then we have the battery handle for wires losing. I also added here a small addition we will look later. And there we have the, I would say, stock additions for wirelessly scanning. We have the mobile phone mount, we have the small adapter plate, and we have the USB cable, but I will leave them in the case since we won't be needing them in my setup. Then, here on the top, this is one of my more interesting modifications, I would say. It is elongated version of this cable. So you can use the MetroY Pro wirelessly, but you can place your battery handle on the workbench or in your pocket, and you still can scan wirelessly. But we'll have a look at it later, and I have to give you some precautions before you think about replicating such a cable. Next one, I have like a Ugreen 100-watt power brick. This is used for the adapter cables I talked about in the beginning, for the PD adapter cables. Important if you want to get such a cable, or I also have a Ugreen power bank that is used for the same purpose. It has to support USB PD protocol with 12 volts and at least 3 amps output at 12 volts. But the Ugreen one are fine for me. Interesting note, the stock power bank that comes with the scanner also uses PD 12 volt output. So that's quite nice, and therefore it can be used seamlessly with the adapter cables. So quite nice that it isn't some proprietary protocol. Then we have marker cards. These are like one of my newer additions, I would say. They are simply black anodized business cards with markers put on them. I guess the first one that came out with such marker cards was ASAP. And they are very handy, as you can see. So you can just spread the cards around the object you want to scan, and you don't need any additional preparation steps. So I got like 100 of these aluminum cards, 150 even, on Amazon for $10 or maybe $15. So the markers are sometimes as expensive as the cards itself, or the more expensive part, it seems, or it feels like. Then the last part we have here in the top pocket is a very small and tiny ASAP can. It's like the scan spray. For those who don't know exactly what scan spray is looks when being sprayed on like white paint. So now it is drying. You see there's like this wet spot in the middle, and when it dries, you have like a very nice white coating that is easy to scan. And the good thing about scan spray, it sublimates, or at least the sublimating scan spray sublimates. This means after a few hours, this will be completely vanished. And at least with the proper scan sprays, like the one from Revopoint or ASAP, these sublimate without any remnants. I also use it on like very expensive prototypes. So yeah, I don't think about or don't have doubts about it actually sublimating. This is like my the can I use in emergencies when I forget my actual scan spray. For normal scans, I have bigger cans. I also have a few cans of the Revopoint scan spray. And I only use this in emergencies when I forget other scan sprays, since they are comparatively expensive in these small cans. The last content is dual axis turntable. The turntable itself is used for the auto turntable mode. For those of you who are like a bit uncertain about the scan modes of the MetroY Pro and how do they, what do they mean? You have 3 scan modes. You have the laser scanning mode. This is basically a bit like a line laser. It projects laser lines and the cameras capture like how the lines deform. And by this you get the 3D object. The second mode is the full field mode. In full field mode, you have like a small projector or like a beamer inside the scanner, and it projects like a line pattern, or it's like a moving line pattern onto the object. The scanner itself can be stationary or can be moved around, and therefore you get like very high detail scans and fast scans. It's way quicker than the laser mode, even though I must confess I don't use full field as much. More likely to be using the auto turntable mode. Auto turntable mode is like the full field mode. It's the third mode. Some people seem to be a bit confused about what auto turntable mode is. In auto turntable mode, you basically set up your turntable, then you set up the scanner on the tripod like this, and while scanning, the turntable rotates, the scanner is stationary. And it's, if I now want to scan this power brick, for example, the turntable rotates to a position, the scanner will take like one single shot, or it's like 3 or 4 shots. But the important part is, while it is taking the shot, neither the scanner or the object itself are moving. Then the turntable rotates to the next position and the scanner takes the next shot. The big advantage of the auto turntable mode is it is way more accurate and you can get way higher detail, since both parts are stationary and you don't have like wobble, you don't have moving parts. This is the main advantage, and it works excellently for scanning very small, high detail stuff. So, and one addition, auto turntable also works wirelessly. I was a bit doubtful in the beginning, since it wasn't like, I didn't quite, wasn't sure if it would work, but it also works wirelessly, so it's very nice, so you can save a lot of cables. In the turntable itself, I added some storage bins. I have designed them for the MetroX and its turntable, but they luckily also fit on MetroY Pro's turntable. And if I open it, you can see 2 compartments. In the first compartments, I simply have marker geometries. The marker geometries are used, so normally if I place the markers only on a flat plane, like this, then I again want to scan my power supply. You have the problem that like this, scanning like this works, since the scanner can see the markers. But the scanner only can see the markers to roughly 30 to 40 degrees angle. So if you want to capture the side of the part and I angle the scanner to the side, at some point it will lose tracking of the markers, and then it cannot scan any further, and you will have to like reposition the object you want to scan and start a new scan. With marker geometries, it's very handy, since you can see if it is placed, it's placed flat like this on the table. And now I have angled markers on the side. So this means if I place my marker geometries around the object I want to scan, and I angle the scanner again to the side, at some point it will lose tracking of these markers on the table itself, but it also will gain tracking of the markers on the side of the marker geometry. So this ensures I can easily move around the scanned part, or the parts I want to scan, and I simply can manage getting a full scan with fewer single scans. So normally, if you would not be using marker geometries, you would be either directly gluing markers here to the side, or you would have to take like 4 scans, 1 from each side, and this simply isn't very desirable. So let's put them away. We will use them later in, I would say the demo scan, where I will show you how I approach scanning. So the last compartment we have, now I have to clean up a bit so it doesn't get too crowded. The last compartment we have is used with cabling and like a scraper. The cabling itself, these are the adapter cables I talked about. As you can see, on one side you have a USB-C plug, and on the other side you have a barrel jack. The MetroY Pro uses the, I think they're called 5521 barrel jacks, so 5.5 millimeters on the side and a 2.1 millimeter pin in the center, with the outside being the ground. They can be bought cheaply on AliExpress. I guess I paid 2 or 3 or 2 euros roughly per cabling. I have 2 of them, since one is used if I use my scanner in the wired mode. So if I use the scanner wired, it looks like this. So in the wired mode, you have the scanner, you have the USB cable, and you have the power cable. Of course, you need some way to feed power to the scanner, and luckily the wireless handle works, since it has a USB-C PD output. What also works is a power brick with PD output, or of course a bigger third-party power bank. So that's simply quite comfortable for scanning. And the second cable is used to power the turntable in this mode. Therefore, if you have a look at my power brick, it has 2 USB-C inputs. Now to the scraper. I have the scraper so I can easily remove markers from any surfaces. This is my, I would say, more aggressive scraper. It has a metal plate. I also have replacement plates for the scraper made from plastic, so I can also remove markers from more delicate parts where I don't want to like scrape the paint off. But it's my replacement scraper. So now let's have a look at how I scan wirelessly. For this, normally you would use the scanner with the I would say power handle. Then you have the smartphone holder in the middle, and then you mount the scanner directly to the handle like this. In my setup, I would say change it a bit, since my use case, or how I like scanning, is placing this power bank in my pocket and then directly wielding the scanner like this, so I also have access to the control buttons. The normal power cable is a bit short for the mobile kit, so I simply designed my own cable, or manufactured my own cable. Majority of the cable is again one of the PD cables, but I added a top section to it with a USB-C output, which can be directly plugged into the scanner like this. And you also see this white block on the cable stating 12 volts. This is important because this is basically the USB-C cable of death. You don't want to plug it into anything else than the scanner, because it directly outputs 12 volts all the time without any like voltage negotiation. The USB-C PD protocol is normally like this. All devices start with 5 volts, and then they communicate with each other to negotiate a proper voltage that the device actually can use and endure. This cable doesn't work like this. It straight up feeds 12 volts into the scanner. This is how the scanner works. I also added like 2 wrappings of insulating tape, so it fits tightly in the port without any wobble, since I don't want to strain the USB port while using it. I will also share this cable design, of course, if you want to replicate it, but you need soldering skills and 3D print, of course. So now I can simply plug in the cable into the power brick, and as you can see, the scanner is booting up, and I can now place the power brick to the side and use the scanner like this without being tethered to the PC itself. So that's quite nice. One further addition to the scanner are these, I would say, lens protectors. They are placed here and here. I designed them using a 3D scan of the scanner itself and using Quicksurface. I wanted them since normally the scanner has a bit narrower, like soft rubber patch for dampening when placing it here on the top side or on the lens side. But since the pad is quite narrow, it was prone to falling to the side or to like tripping over. So I simply designed these bumpers, printed them from TPU, and used some reversible smartphone double-sided tape. So it's commonly used in smartphone repair, but it holds on quite nicely, but can be removed without leaving traces. So now it can be placed here in the top and isn't falling over so easily. So now we have looked at all of the parts in the of all my, I would say, kit layout, and now the next step will be actually 3D scanning. For this I will now start screen recording on my notebook, and I will take you with me on the, I would say, scanning journey. This is like no actually very powerful workstation or work. Generally for scanning I use a powerful workstation that's currently at my office. This is like a Lenovo Slim and Light notebook. As you can see, it's quite thin, but it features like it's NVIDIA 3050 mobile. It's i7 11700H, I think, and 16 gigabytes of RAM. I would say the 16 gigabytes of RAM are a bit of the Achilles heel of this notebook. So with other scanners, I have no chance scanning with it. But luckily, the MetroY Pro isn't as, I would say, RAM hungry. So it works with it. So the scanner is booted up. And now, as we're in the software, I first need to connect to the Wi-Fi of the scanner. How it's working, the scanner is basically hosting its own Wi-Fi hotspot, and then you connect your notebook to it. So you can see MetroY Pro Revo. This is the correct one, so I will connect to it. And I also will take a sip of water. Now it is connected, and you also see the scanner connecting here in the software. Now it normally takes a few seconds, but here we are connected over Wi-Fi. So I can start my project, and I will name this Demo Scan. You can also set a location where the scans are stored. So normally, or luckily, it's RevoScan always stores the scans outside of your documents folder, so they don't get backed up by OneDrive. With another scanner, I had a problem that the default scan location is within the documents folder, and it suddenly tried to back up 300 gigabytes of scan data to my OneDrive, and I was quite surprised why my internet connection throttled. So we will create a scan. And we will also have a look at what we will be scanning. We will be scanning this. This is FPV goggles for my FPV drone. And basically it's VR goggles without the VR part. So you're not seeing like a virtual reality, you're seeing a live feed of the drone. It works like this. You have a camera on the drone itself. You can see it here a bit. We have the camera lens, and we had on the side of the drone, you have the transmitter, and in the back the antenna. And the goggles receive the video feed and play them back. You don't have like any stereoscopic 3D, but we have a very low latency link. And as you can see, I already designed some parts for the goggles. But now I would really like to have like a proper fitting foam cutout for my transportation box. Currently it's just in like a rectangle square. And I guess this will be a nice case to use the scanner. As you can also see, the front part is semi-transparent. And also we have these high reflective black parts. To be capable of scanning the front part, so this transparent plastic, we will need to use scan spray. When using scan spray, generally speaking, a very thin coat is often better since it dries quicker. So, like this. Since it is sublimating, you can be quite, I would say, quite generous applying it. So overspray isn't much of a problem. Now we simply place the object here on the workbench, or the goggles on the workbench, and in the first step I will place marker cards around it. You could also like directly glue the markers on the table or glue it on the goggles, but I will place my cards around it. This simply is more efficient, or is faster, and you also don't waste markers. So I'm quite against just using markers as like disposable parts. The next step we will using is my marker geometries. They are just picked from the box, and I will place it around the object. So maybe a few more. So from each side I have enough parts. So like this. Maybe one more. Now we have everything prepared, and we can now set the proper scan settings. Since I will be only using the cutout of the scanner, a resolution of 0.4 millimeters will be fine. I will be using cross lines, but you can also change them while scanning. Then I will be using marker tracking. For such a small object, I don't need global markers. Global markers is basically capturing all the markers before starting the scan, and it then does some optimization of the markers or of the captured markers, so we'll get, generally speaking, better tracking performance, but for such a small part it isn't needed. And we have like, I would say black object type. Normally it's more like general, but you also have these very dark plastic parts here in the back. Marker diameter is only used 6 millimeters. You can also leave them on. I will leave them on. You don't need to manually deactivate them. So to set the exposure, I will be simply pointing my scanner at the part. And one additional step you must take when using my design for the cable. Normally in wireless mode you have the scanner mounted to the power bank like this, so the camera view is tilted. But luckily you can change this in the software, otherwise it can get quite confusing. So it looks fine. Maybe let's reduce the exposure a bit, and now we can just start scanning. While scanning, it's basically a very straightforward process. You just like want to paint with your scanner around the object. You will try to capture the object from all sides. And in the software you set a target point distance. So I set it to 0.4 millimeters. This doesn't mean that it is capturing at 0.4 millimeters. This does mean it is like showing you in the preview the target you want to reach. So as soon as the whole goggles reach this, I would say how it is called, it's a bluish, a bluish color tone, you captured enough data, so in a later step, when actually fusing the data, the target resolution can be reached. So it's more like an indicator that that you collected enough raw data. It's like raw data input. So now for the bit harder to reach areas, we will switch to the parallel line mode. With the latest software update, the mode switching became a lot faster. So initially with the first software version, it took a few seconds to switch the modes, or like 10 to 15 seconds, and it automatically paused the scan. But luckily with the latest update, this isn't the case anymore, since this was quite cumbersome to scan. So guess we captured all the necessary data from side 1. So we can pause, complete the scan, and simply turn the goggles around so I can capture from the second side. I guess I will also turn them around like this, so I have a bit of a better access to the back side, since the front side is quite easy to scan. So let's create a new scan. It automatically sets the same settings as in the previous mode, or in the previous scan, so there are like no changes to be done. But keep in mind, if you changed, okay, I already did like a small mistake. I changed the scan mode, and if you change the scan mode, it also resets the other parameters to the default values. So I will now go back to my black object setting, and I can start the scan on the second side. So it looks not quite nice. So I can just start scanning. And it is, yeah, a very fast process, I would say. So you really notice the difference coming from a MetroX. As my previous, the MetroX actually was my, I would say, first proper laser scanner, or like my first laser scanner. So I got the original Raptor scanner, Quality Raptor scanner, which only featured like 7 parallel lines and no cross lines. And then, like 2 days after receiving the scanner, the Kickstarter for the MetroX was announced. So it was quite, I would say, fast decision for me to send the Raptor back, and yeah, get the MetroX. And it didn't disappoint me. So as you can see, I nearly finished capturing the second side, maybe a bit more here in the front. With the ASAP spray, you have to keep in mind the time it takes to sublimate, so to disappear, is dependent on the temperature. So currently I'm here in my workshop, and it's quite cold. So it will maybe take a few hours to sublimate. But in the summer, or if you are in a very humid area, or like tropical area, it can sublimate in 10 to 50 minutes, but there are also like different recipes of scan spray available with different sublimating times. So I guess the longer one is the ASAP orange spray, and it takes, I guess, 24 hours to sublimate. So let's capture a bit more on the side of the goggles. But I guess with the first scan we already have enough overlap to actually complete the scan. I guess with the buckles for the head strap, I will be having some white spots or some missing spots, but they aren't as important to capture for me. So maybe here a bit on the top. Now we can also pause, and while pausing we can have a look at the preview to search for any missing spots. But this looks good. So we can simply complete the scan, and now I'll go into the post-processing. For the post-processing I will now completely switch to my PC, because everything from here on will be done inside the software. So, first steps is I generally like to rename my scans. You don't have to rename them, but for larger projects it can get quite confusing if you start to have like 10 single scans, and you don't know which one is which, especially for very large scans where like loading the preview takes a few seconds. It's easier to directly see the name of the scan. So for a scan, the normal processing steps are fusion, isolation, overlap detection, and meshing. You also could use the one-click post-processing or one-click edit. This works great for single scans. We don't need to combine multiple scans as we need to do here. But I will now use fusion. I will set my resolution to 0.4 millimeters, since that's fine for me. I will use the high quality fusion, and I will also use batch processing. Batch processing allows me to simply select multiple scans, as we do here, and perform the fusion for all of the scans. So let's start post-processing the laser scan. I already have used the 2 scans of site 1 and site 2, as you've seen. In the meantime, I switched to my desktop PC simply because I have a Space Mouse. Space Mouse or Space Navigator, they're called. Quite nice. They're like fancy PC mouses for 3D navigation. So as you can see, I can move up and down, front, back, left, right, and I can of course rotate in all the axes. They take a bit of getting used to, but the usability is quite nice. So before we can merge the 2 scans, so merging is meaning that we combine 2 scans. So because we have like scanned the top side, then we have scanned the bottom side, we will first have to cut away all of this table. To assist with this cutting, I can set under display orthogonal view. So we don't have like any false display due to perspective, and I can much more easily delete all of the data. So like this, we can delete it, and in the next step I will simply select a small piece of this one and select connection like this. Now I selected all parts of the scan that are connected to the main piece, and by inverting the selection and deleting all additional data, I can nicely isolate the scan. We will do the same for the next scan, and as you can see, the post-processing workflow doesn't take a lot of time. So the step that maybe takes the most time is the fusion part, but this is also mainly caused because I quite like to use the high quality fusion. To be honest, I haven't tried out the fast fusion yet. So then after we isolated the scans, we can move on and merge the scans. This is simply done by selecting the merge tab and selecting the 2 scans we want to merge. There are 2 options. There's the feature merging and the manual alignment. Feature merging is basically like automatic merging. So we can now preview it, and it actually should work quite well because there is a lot of overlap between the scans. So you have to keep in mind, for feature merging to work, you need to have sufficient overlap between the scans. But as you can also see, here the tabs on the side, they moved during scanning. So before continuing, I will actually delete the tabs on one of the scans, so I don't have this much of an overlap. Just like this. I just want to have like a rough deletion. It doesn't need to be very detailed. This will suffice. So, and we can go back into merging. It still kept the merge, but I will also give you a demonstration of the manual alignment. It's basically point picking. You open both of the scans, and then you pick common points between the scans. So let's have a look. I will pick this one and this one. Then we can pick the screw on the other side. And now in the third point, and the third point will be by like the top hole here. So now it looks fine. It also does some automatic alignment too. So your manual point picking is mostly like indicating the software where to look for overlap, and then it does automatic alignment. So it's not only dependent on your own picking. So now I can go to the isolation tab, and we can look at the new model. It's called Merge 1. That's like, I would say, a standalone feature of RevoScan, that the merging actually creates a new model you can separately edit. I quite like it. And we will name it Goggles Laser. So then we will perform isolation. Isolation is basically deleting any small free-floating points. You can also set a scale, how big how much of the point cloud can be isolated. So if I set it to 100%, I didn't actually select anything because there is only one body. But generally speaking, I set it to the default value. Next step will be overlap detection. For this one, I also use the default values, and I see the overlap it detected. So the overlap is basically after merging the scans. There could be like points that aren't closely matched together, but there's like 0.5 millimeter of distance between them because maybe some of the parts moved, like here on the head strap buckle, or here at the side, the ventilation grid. They're like very tiny holes that can be like misscanned. So the overlap detection simply deletes all of this arbitrary data. After the overlap detection, we can straight on go to meshing. There is potentially the option to smooth the point cloud data at this point, or even simplify it, so you get a lower count of points. But these functions can also be done after you have created the mesh or generated the mesh, and I think this is like more easy to do afterwards. And I actually don't want to edit the point cloud data in like this static way, and I prefer like in my temporary mesh to edit. So meshing can also be done in the fast mesh or high quality mesh. I will again using the high quality mesh, and for the quality I will be setting it to the default value or to the recommended value. Actually, I'll be setting it to 0.4 millimeters or closer to 0.4 millimeters, and I won't be filling holes. So fill holes is used if you have like here these small gaps behind the buckle where it didn't scan. They can be automatically filled, but since I won't be 3D printing them directly, I also won't be using the fill hole feature. So if your goal is to 3D print, then you should use hole filling, because the 3D printing software, so the slicer, requires a manifold surface, so a surface without any holes. So it can determine what is the object and what is not the object. So now you can click on applying, and the meshing process is quite fast. So if we can have a look at Task Manager, it actually doesn't take too much of the resources. So it currently mainly runs on, I would say, 2 CPU cores. We have 17 gigabytes of RAM used. So yeah, now here we have the mesh of the goggles. Keep in mind I scanned at quite a low resolution, so 0.45 millimeters. If you want high detail or very high detail, it of course will take a higher resolution, but it also will take longer in editing. I simply chose this resolution so you can get like I can guide you through the software without waiting too long for the meshing. So if I take 0.1 millimeters resolution and then I maybe have 2 million vertices, the meshing will take considerably longer, but this is expected. So the next step for the scan of the goggles will be alignment to the coordinate system. This step is quite important, I would say, since it is needed to then use the scan or the mesh file in later steps in CAD software or for reverse engineering. For this, I will be using Quicksurface. Quicksurface is a reverse engineering software. So it's specifically designed to work with scan files and edit the scan files and also create CAD features or CAD files based on the scan files. So theoretically, you could also use regular CAD software like Fusion or SolidWorks. Fusion actually is somewhere in between traditional CAD and I would say reverse engineering software, because some of you may know MeshMixer. MeshMixer also was an Autodesk software, and at some point it was integrated into Fusion. So it actually contains quite a few or quite a lot of mesh editing features. But I use Quicksurface Pro most of the time, or nearly all of the time. You have to differentiate. There's Quicksurface Lite and there's Quicksurface Pro. Quicksurface Lite roughly costs, I guess it's 400 euros per year for private persons, or for a 1 year license. Quicksurface Pro is more expensive. It's like 5,000 or 5,500 euros for one-time fee, or for like lifetime license, or 1,500 per year, roughly. But there are like vast differences in capabilities. Quicksurface Lite mainly lets you create base features of the scan file. So, for example, you load a scan and then you can automatically fit a CD surface to it. And Quicksurface Pro is basically a whole CAD software packed into this on top. So it can even construct whole parts, like ready to print parts, ready to use in other project parts. So for me, the Quicksurface Pro was the more obvious choice. So let's open the scan of the goggles. And as you can see, if I will be looking on the part from like the different angles, it doesn't fit at all. In Quicksurface, what's quite nice, there is you could like theoretically go through the workflow all the way by yourself, using the different tools for mesh editing, like editing the meshes for filling holes or deleting parts. But what you can also do is simply selecting the scan and select prepare scan. Sometimes for larger scans, the first step it will prompt you to do is reducing the point cloud or reducing the point cloud size. For this one, it won't be necessary since we are under 1 million triangles. For myself, I roughly most of the time try to stay below 2 million triangles. For uploads to Sketchfab, roughly 4 million triangles. So my rule of thumb is 3.9 million triangles will be just under 100 megabytes PLY file when I export it from Quicksurface, and 100 megabyte is the limit for Sketchfab. If I want to share any scans for other projects, I can use any size I want, but above 10 or 50 million triangles, it gets quite imperformant. But I already have quite a powerful PC, so I have a RTX 5070 Ti, 64 gigabytes of RAM, but at some point you simply don't have enough power. So how to edit or how to perform the prepare? First step is the edit scan feature. There you can delete any unnecessary parts. It's a bit like in the Revopoint software with additional features. So for example, I have this remnant of the strap that moved. So I can just now delete it. This one I want to keep. So I guess that's the only part I will actually delete. Then the next part is deleting small meshes. So let's have a look at it. Okay, it seems like we have one main mesh and several other very small meshes you don't even see, like especially here around the vents. So I can just click on my main mesh and select it as the only mesh that will remain. Then we have hole filling. I guess I will only fill very small holes. There's a nice feature in Quicksurface where you can basically, as you can see, we're currently having 25 holes. And now I can measure a hole size I want to fill, like this, with a diameter of roughly 5 millimeters. And now I can fill all holes that are under this size. And it did, and now we have 13 holes left, and this will be fine for me. Maybe let's fill this hole. Okay, let's not fill this hole. So then next step will be creating a symmetry plane. For alignment to the coordinate system, you can draw planes like in the next step, but most of the parts you will be scanning, if you're scanning mechanical parts, will have a symmetry plane. For this one, I will first create like a rough sketch of the plane. I can now actually manually refine a bit, like this, or maybe so move it a bit like this. And now I can rebuild the plane automatically. The rebuilding step will be more precise and faster if you already start with a good sketch. I can also analyze it. So you can see, maybe let's move it a bit to the side. This looks... Okay, I guess I'm making it worse, but let's rebuild it again. I have quite a few of 3D printed parts on the goggles, so the whole faceplate is 3D printed, the front is 3D printed, so there won't be any like fully accurate match. But this will suffice for the alignment. And now we need 2 additional planes. So we already have our symmetry plane for one axis, for the x-axis, and now I will need a plane for the z-axis and y-axis. For the z-axis, I will use these 2 knobs as a basis. This looks good, and I can also set constraints, and as you can see, it already set automatic constraints to make it perpendicular to the symmetry plane, so this looks fine. And now I need one more plane, and I will use this one as the plane. So let's look. It also set the constraints correctly. I can create it, and now the next step will be the actual alignment. In Quicksurface, you have basically, you need to pick 3 planes or other features for alignment, and the order is, actually for the order, it took me very long to understand it. I'm a bit ashamed of it actually. So the 3 steps are, you first pick the plane that defines the z-axis, then for the x-axis, and then for the y-axis. So z-axis will be this plane, and now I will actually flip it so the z points to the top. Then the symmetry plane for, the second step is actually the y-axis, so like this, and the third step will be this plane to define the x-axis, so the symmetry plane. Now we are fully defined, and I can click on apply and finish. And now you will see it looks quite nice. So for the second part, we will try out the auto turntable mode with scanning the small bus that's included. I will just get a ruler and look at the dimensions of the bust. It's roughly 6 centimeters tall, and the nose is 5.5 millimeters wide. So you have a reference later when we will be looking at the results. So for using auto turntable, you need the scanner, you need the turntable, and you need the tripod for the scanner. So let's first mount the scanner to the tripod. The scanner is already booted up, so I don't need to start it again. And I will also have to point the scanner at the turntable. Next step is connecting the turntable to the power supply. I will be using my adapter, or it's the adapter cable, and I will be using my power bank. So I will just plug it into the power bank like this. So it's a bit firm, the plug. So now it's plugged in, and actually I'm seeing if you can read it. The power bank states 12 volts out at 0.3 amps. So let's place this to the back. You can also manually control the turntable with buttons on the side. But for the auto turntable mode, the turntable will be controlled by the PC. So on the PC, I will perform a feature scan for the bust, since we have quite clear features and I simply don't need to use markers. On the turntable, you have a bit of a more complicated situation, since the turntable also can tilt to the side like this. Only placing marker geometries on it can get quite hard, because at some point, if we tilt it now manually, the markers will start to slip off the turntable. This can be solved by either using like sticky markers or sticky marker geometries. I also included magnets into my marker geometries, and I have like a metal plate to put on this turntable, and then the markers will hold. But for this scan, I will just use the object. So now in the software, I will set my scanning mode to, or let's actually start with a regular full fields then. If we are already in a mode, this will be quite interesting, I guess, because I haven't really used the full field mode that much, to be honest, because I'm either using laser mode or using the automatic turntable mode, but let's try it out. So depth exposure can be set to automatic here. We have a general object, you don't need the black object, so I can just, I need to move. Yeah, as you can see, the white part gets overexposed quite easily. So I need to set manual exposure. I also can zoom a bit in the preview, since you have such a small part. And now let's just scan the bust. And as you can see, the full field mode is quite fast. So I guess the front will suffice for a very short test. We will look at the results later. But now let's switch to the auto turntable. I will attach my tripod again, as you can see here. And the tripod head, also the tripod itself, can be extended to set a certain angle. And you also can tilt the scanner on top of the tripod quite freely. So, like this. Now, the software is still switching the state, but when it is done, it's okay, now it's finished and I can start a new scan. I will place my head in the middle. I want to scan it quite from the front. So currently we are, so now you see you have the preview of the depth camera and preview of the RGB camera. For the depth camera we will set the exposure to the minimum value now, because it's such a wide object. We can keep the object type to general, because it's not a black object. And now we can connect our turntable. The turntable itself is a Bluetooth device, so that's quite nice. You don't need to plug any USB cable into your notebook. Now it's connected. And I only want one rotation. And we will use a scanning interval of 15 degrees. So here you can set the turntable behavior. You can set how many rotations it will do. For the rotations you can then also set the tilt angle. Since it's a dual axis turntable, I will only use the scan from 0 degree tilt, since I only want a quick example. So in the next we have this distance bar. I may have missed this one while laser scanning, but you always have to try keeping this distance to the scan subject in the green area. Most, ideally we want to keep it in the excellent value. Sometimes this cannot be reached, but generally speaking you have to try keeping inside of the green area, otherwise the tracking may even fail if it's completely outside of it. Now let's try upping the exposure a bit. This looks fine. Some people often seem to be confused why you are only getting 2.6 FPS in auto turntable mode. This is due to the fact that you're basically taking single shots. You want to take still shots, and there is no reason why it would scan faster. Now we can start scan, and as you can see now, if we zoom a bit out, you will quickly see like the single scans it takes. So yeah, it took the first proper scan, and here you can see the camera view. If you are accustomed to Blender, you may know this look, but now we should start seeing like the camera orbit around the head to be created. And from the first look, the result or the details look quite nice, but of course, yeah, the best impressions will be seen when the scan is finished. But yeah, I will let it scan, and then we will be back for the post-processing. So now we are finished with the scan. It seems like it kept tracking all the way through the scan. So I can complete the scan and we can start with the post-processing. So now let's process the scan results of the full field mode and the auto turntable mode. Let's start with full field. I will do it in the same fashion as for the laser scan, so I won't be walking you through it as closely. For the point distance, I will use the recommended value for full field. The recommended value is dependent on the data quality you captured. So this is the senseful approach, I would say. So you could, of course, set it to a lower value of 0.05 millimeters, but then you have the problem that you didn't capture enough data to actually achieve this resolution, or to reliably achieve the solution. You're basically generating artificial noise, and we don't need it. I can now directly jump to the isolation, the overlap detection, but I guess there will be no overlap, and now to the meshing. Keep in mind, for this full field scan, I only scanned from the front side very quickly. I didn't scan from multiple positions. I didn't scan from the bottom, but this is more like a small demonstration for you how full field looks like and how the results look like. You could, of course, reach a very higher resolution if you scan longer, but for like the freehand scanning, I most of the time prefer using the laser mode, and the full field mode is also used in the auto turntable, and there is more, I would say, more suited. So now we have the auto turntable scan. For this one, I will also use the recommended resolution. Maybe we will even go down to 0.1 millimeters. That should be fine. And as you can see, for these smaller scans, the post-processing is very fast, so you don't have to wait long. That's often an advantage of scanning smaller stuff. Now we can again delete any of the markers it captured. So these are like the white reflective markers on the build plate. The build plate itself in black wasn't captured, but some of the inner circle of the markers was. Now we can isolate, detect overlap, and straight on go to meshing. And let's look at the results. I've shown you the size of the like the small bust, so you may have a good feeling for the size comparison. But looking at the results, it's actually very, very nice. You see there's a bit of like surface ripple. This can be created since I selected a lower resolution for the fusion than it prompted me, or than it suggested. I also have like 2 million polygons in this one. So maybe let's redo it in the recommended setting. This won't take long, so that's quite an upside of working on a powerful PC. And like the post-processing very nicely scales with the hardware you got in your PC. So we can go back again, delete the unnecessary points, isolate, make the overlap detection, there wasn't any, and fuse or mesh in the recommended settings. And as you can see, it is way smoother now. We don't have this small surface ripple, and we only have roughly 1/4 of the points we had previously. And a nice trick in Revoscan, currently see the part isn't like orbiting around the part itself, but when I press Alt and click on the part, then it orbits around the picked point. So this may be quite handy. There is actually in the help section, there's like a user manual where all of this is documented, but most of the people won't read it. But yeah, I would say for a part roughly, I think it's 5 centimeters tall, it's quite nice. Let's now go to hole filling. We will use this. So I will fill these holes it got. Keep in mind the hole exists because I didn't scan the part fully, or I didn't tilt the turntable. But this will also be a quite nice demonstration. So it's basically selecting the filling method. So there's plane and curved. Plane, it will just fit in a plane, and curved will fit in like a surface tangent to the vertices around. So let's start with curved. For all these holes, for like the small holes on the head itself, apply. And now let's fill in the bottom as a plane. Okay, and let's see if there are any more holes left. So, all right, it looks like we have a manifold object now, and we can theoretically directly 3D print this one. So I will just open Quality Print now. Then we can export the mesh model. So here you can see you can export all the different steps. You can directly export the point cloud, but you can also export the mesh now. We will export it as a STL file. I commonly prefer exporting as a PLY file because this is a more efficient file format than STL, and can also store like additional values like normals of all the vertices. But the slicer generally can only work with FreeMF, STL, and OBJ. So we will use STL now. And when you now go into the printing software, I will select my K1 with a 0.4 millimeter nozzle, standard settings. So, and there you can see our mesh. We can now like auto orient it and slice it. So yeah, I would say you can directly print from the scan itself. That's quite nice. Maybe let's cut on the bottom a bit. So cutting features here, like this. I will use the PLA in the printer, and let's start printing. After roughly 30 minutes, the print of the bust was completed, and looking at the results, they look quite nice. Of course, you have, I would say, loss of resolution with the 3D printing process, but setting them next to each other, first looking from the front and then from the back side, looks quite good. So yeah, this was my tutorial on how to use the MetroY Pro. I may have missed some spots, so I didn't show you the mirroring feature to the smartphone app. if you're interested in this one, I can of course show it to you in a later format or like in a shorter video. But for my workflow, most commonly I don't use it. So I use the scanner most of the time at my workbench, where I directly have my PC monitor or notebook directly next to it. And yeah, so I would say if you have any questions left about scanning workflows, maybe my advice for scanning or scanners themselves, just write a comment or contact me over DM.